Good morning, everybody, and welcome to our next monthly Mass Timber Forum session. My name is Matt Holman, a partner at Gardner & Theobald. Today's session is focused on cost, programme and procurement, and with a significant amount of content we want to relay to you all today, so I hope you're all awake. The style of the session today will take a different form to the previous ones, not least because all of our panellists today are from G&T. So we've gone for a more presentation-based approach as opposed to our normal Q&A style. So our agenda today, I'll firstly be introducing you to our panel. We'll then split the main part of the session into two sections, the first being design and pre-construction and the second being construction delivery. We'll hopefully have time for some live Q&A during the session before I then wrap things up by informing you of our panellists for the next session in 2021. During the session today, we'll be weaving in our usual poll questions, firstly to make sure you're all awake, and secondly to also help inform our report that will summarise the outputs of the session. As with previous sessions, our summary report also gives us the chance to present answers to any live questions that we don't get a chance to answer today. So, for our panel today, we have the following. Myself, Matt Holman, a board member partner at G&T, operating in the project management division of the firm. I've been at G&T for 20 years, operating across a variety of sectors, including the office, residential, retail, leisure, sports and hospitality sectors. Steve Bennett. Steve, I'm sure, is well known to most, if not all of you. Steve is a board member partner at G&T, leading the cost management division of the firm. I won't embarrass Steve by noting how long he's been at the firm, only to say he's longer than myself. Steve has an exceptional CV, advising an array of clients across a wide variety of sectors, which closely align with my own. In addition, Steve also offers a very strong master planning skill set to our clients. Steve is also a fellow of the RRCS. Oliver Booth. If Ollie wasn't well known to you before this Mass Timber Forum series, he should be by now, as he's an intrinsic part of the MTF team here at G&T, and indeed it's his brainchild. Ollie is a product of our graduate intake class of 2006 and is a partner of the firm, working closely with Steve in our cost management division. I think it's fair to say Ollie is recognised within the industry as an expert in mass timber and MMC, and we are very proud to offer such expertise to our clients in what we see as a growth technology in the industry. Ollie is also a proud member of the Trada Advisory Council. Paul Robinson. Paul is a partner working within our project management division and leads our programming and construction logistics team. Paul has a wealth of experience and has become a vital part of our service delivery across a wide variety of sectors and construction methodologies. Jessica Pennell. Jess works with myself in our project management division and is one of our brightest rising stars. While servicing some of our biggest clients, Jess also has the unenviable project management task of managing Ollie and myself as part of this Mass Timber Forum series, and I hope you agree she's done a pretty good job so far. You may also recognise Jess as one of the coordinators of the most recent BCO technical guide. So let's get things started. Let's have our first of our three poll questions today. So the first question is, what is the main driver behind your aspiration for using timber on your projects? Embodied carbon or carbon offset, sustainability, health and well-being, cost, programme or aesthetics? If you can click one of those, we'll give you a few seconds to answer that. Drum roll. I think the answer coming in. Okay, so the answer's coming in. Leading away was sustainability with 46%. Second there was embodied carbon, so carbon offset with 31%. In third was health and well-being at 12%, aesthetics 8%, programme 4% and cost 0. Okay, that's great. Thank you, everyone. So I'm now going to start the first part of the session and we're going to look at design and pre-construction. So Jess, if you could start by, let's have a look at the key drivers behind this, please. So Jess, if I hand over to you.
Yeah, thanks, Matt. During the design phase, there are some key drivers that have to be considered prior to making the decision to go with a mass timber solution. So why are we considering mass timber now? It is now being considered by developers more than ever as a result of the increased focus on sustainability aspects of construction, with one of the key drivers for this being embodied carbon and carbon offset. And as we've just seen from the poll results, sustainability has come out as your top key driver. Timber solutions are the only renewable building material and can link with corporate social responsibility aspirations. For instance, non-timber solutions now incur a carbon tax, which is supported by policy, and these factors are starting to drive towards low carbon and carbon neutral solutions. It is important to really consider what the project goals are for sustainability and how this links with the local planning strategy. This all closely links with the health and wellbeing matters, which are now at the top of the agenda. And of particular note are the beneficial aesthetics provided by exposed timber elements, which can form part of achieving positive impacts on health and wellbeing. Improvements in technology and modern methods of construction have enabled timber solutions to become a more viable option, where for many years they have only been aspirational. The development of hybrid options enables some of the barriers of entirely mass timber projects to be overcome, such as performance in the event of fire and some of the concerns we heard from the insurers at the start of our Timber Forum debate. Also, the growing knowledge on mass timber solutions from research and testing in Europe and worldwide is informing engineering solutions, particularly with regard to fire engineering, all of which can assist you in defining whether timber is the right option for your project. We must also consider the intended use of the building, be it commercial, residential, educational, or retail, and the structure and form of our intended development. If the form is simple and large spans are not required, timber solutions are appropriate. However, if the building has a more complex form with larger spans, then alternative solutions may be more appropriate. Considering each of these key drivers will enable you to conclude whether timber is the best and most suitable solution for your project. If it is deemed that mass timber is the way forward, then the next step is selecting the project team. It is important to appoint a team of consultants with the right level of knowledge, competence, experience, and expertise to take forward mass timber buildings, with key early appointments to include the architect, structural engineer, fire engineer, and building control. Matt, on projects that you're working on through the team, are you finding that there's a premium to pay on consultant fees on timber projects?
Yes, Jess, there can be. Three main reasons, really. Firstly, the involvement of an expert of special advice can be earlier than usual in the process of a normal project, for example, a fire engineer, and therefore there's a need for a higher time input and therefore fee requirement. Secondly, there can be a need for a wider variety of specialists, including the early involvement of subcontractors and manufacturers for design services and possibly off-site testing. And lastly, as we've covered in our fire testing and building control session, it is recommended that a peer review team is procured, particularly for the justification of fire engineering and structural engineering designs. So yes, in summary, probably yes.
Thanks, Matt. And as Matt has just mentioned, you may also need to build a team of peer reviewers to complete a peer review during the design process to validate the design, particularly in regards to fire and structural engineering. As highlighted previously in our fire testing and building control forum, it is important to appoint this team to assist with the building control process, and they suggested that this could even be an academic engineer. Another key step is to engage with key stakeholders early in the process. You may recall this stakeholder diagram from the introductory forum. As for every project, awareness of key stakeholders and engaging at the start is key. When considering mass timber as a frame solution for a project, it's important to understand the key stakeholders who would be involved at the outset of the project. These range from the project design team members to governing bodies, regulators, insurers to manufacturers, suppliers, forestry and subcontractors, not forgetting the end users and public perception. As highlighted by panelists on our earlier sessions, early engagement with the local fire brigade, insurance brokers and risk assessors is highly recommended and particularly important for timber projects. We touch on consideration of many of these key stakeholders throughout this session as we continue through the steps of the project process and programme. Moving into the design process, during the design phase, the consultants will need to consider and establish the extent of mass timber use, be it a full timber structure or a hybrid of timber and steel frame with timber floor panels. In my experience, it's necessary to undertake site surveys at the early design stages, particularly for cut and carve projects, to inform the design development and avoid problems later down the line. As highlighted in the Best Practice in Construction forum, design information and design freeze will be needed relatively early in the design process to undertake testing, engage and obtain buy-in from the key stakeholders, and for the negotiation of pre-construction services agreements. Early selection and design of the cladding system is needed so that it is built into the design from the onset. This may need subcontractor input and therefore need to be procured under a direct design appointment, leading to a pre-construction services agreement. Following this process of early subcontractor design engagement, that will enable the piece count to be established early and ensure the size of the components are identified such that they can be delivered to site in the most efficient way. This, along with the lifting strategy, is key to the completion of the structure, and Paul will touch on this later when he talks about the programme. It is important to ensure that the fire strategy is developed and correct for the use of the building, along with clearly defined structural tolerances and consideration of vibrations and movement, as well as acoustics. It is key to consider the sizing of the floor panels to allow the main structure to be on the correct grid, which will be discussed further in our future Structures MEP and Acoustics Forum session next year. Overall, mass timber lends itself to utilising BIM for both the design coordination and to enable the design for manufacture elements. I'll now hand over to Matt for the next poll question.
Great. Thanks, Jess. Excellent. Good start. So poll question number 2, everybody. This is a quickie. So let's just get that on screen. So in your experience, is it cost that is a major barrier to using mass timber? It's a very simple one, this one. Yes or no, please. Give you a few seconds to answer that. Okay, the answers are coming in now. Oh, that's interesting. So it's a 50-50. Very interesting. So 50% yes, 50% no. So very interesting indeed. Thank you, everyone. So that leads into our next session, or next part of the session, to Steve Bennett on cost considerations. Steve, over to you.
Thanks, Matt. Interesting result there. So morning, everybody. So I think before we think about the cost of timber frame buildings and how they're efficiently delivered, it's probably helpful to step back for the benefit of some of those on today's call to recognise that the construction cost of any building is driven by a combination of factors. And you can see them on this slide. They boil down to form, use, location, and materiality. And the interplay between those factors will generally drive the method by which those buildings are most economically put together. So if I look at form, and by that I mean the height, shape, grid, and position of the building, that's probably influenced by its use. That is, whether it's an office building, a school, or a residential dwelling, for example. And from there, you might think about its location. Can I easily build this building because I have a readily accessible site? Or am I in a remote location trying to build a lighthouse exposed to the elements? So together, all of those factors help influence materiality. The form, location, and use leads us to a solution or a series of solutions, a series of material solutions. And from there, we can look at what's most economic. There are, however, a further series of factors to think about, and Jess has mentioned them already. Aesthetics, carbon, sustainability from an environmental and health and well-being perspective. They're big considerations now. But of course, there is also just plain old choice. So when it comes to timber, choice has only recently emerged as engineered mass timber has been more widely and commercially available in the UK, with an ability to perform in a manner more like the traditional structures of concrete or steel frames in offices. If we consider an office building, it might typically have the distribution of cost proportions shown in this diagram. the spread of that cost, of course, that's going to vary in every building, and it's going to be driven by those factors of form, location, use and materials. The timber in the structure can also have an influence on some of the other elements of the buildings, impacting the cost distribution. So they might be, with timber, the potential for reduced foundations, is timber generally weighs less than other solutions. An influence on finishes, as there's often a preference to leave the timber exposed. That can give a benefit of not having to apply ceilings or internal wall finishes, for example. And subject, of course, with any of that to matters such as fire and spread of flames. And Ollie's going to talk a bit more about that in a moment. So what you're really interested to understand is the cost of these various solutions. So let's have a look now at the relative cost for different framing solutions. The exercise we've looked at here is for a low-rise, regular gridded office building. Every building needs to be considered on its own merits, and many of those engineers on the call will tell us that anything is possible. It is, but at a cost. So typically, a steel frame can be more cost efficient over longer spans than concrete. In this example, a typical 9x9 or 7.5 by 12 metre office grid, you can see that reinforced concrete might sit in the range of £300 to £325 per square metre of gross internal floor area, and a steel and hollow rib solution slightly more at £325 to £350 a square metre. Not really a huge difference in it. There might be a small premium in steel, but that can depend on market conditions, steel prices, contractor selection, and regularity of the grid. I should add that our models here include a concrete core for all of the buildings, and the stairs are part of the cost too. If the buildings were taller, the cost would certainly be higher. Cost does change for other methods too, such as post-tension flat slabs, which are again more expensive. So moving on to timber. You can see that by adding a timber component, the price steps up quite significantly. I should add that these costs are all supported by some live schemes that we have on site at the moment, and each system has been price checked with the market. So taking the first of the timber options, that's the center one on your screen now, introducing CLT as the slab has a premium over a concrete and rib. Potentially taking the cost of the frame up to £420 a square metre, or a 25% premium. Moving on, glulam and CLT. Here, we've moved the frame entirely to timber, so the columns and beams, as you can see in that image there, have now become timber as well as the slab. And you can see that cost step up again, potentially up to £475 a metre, or a 50% premium on the traditional solution. And finally there, laminated veneer lumber, or LVL. This introduces hardwood to the framing, and in this case it's a Barbuka beech, which is a higher strength and can allow for longer spans with lesser member sizes. Perhaps starting to replicate steel frame spans, it's a more durable finish and is visually often preferred. But at a cost of up to £550 per square metre, or what could be a 70% premium, it's quite a significant cost difference. Ollie's going to dip into some more detail in a moment about the various components that make up those frames. So as you can see in the frame comparison, there are some quite significant variances in the structural framing solution costs, and certainly a premium to pay for timber. However, if you put that into the context of the building as a whole, the differential might not appear quite so dramatic. I would add here that we've expressed now in pounds per square foot rather than meters as the structural frame, because I know for many of you watching, it's a more familiar expression of pounds of cost. So you can see the difference there, but importantly, there are further benefits to be taken than in the cost ranges shown on this slide. If you take a decision early to consider a timber building, these options can get closer in cost to one another through potential benefits from, as I touched on before, a reduction in foundations, less interior finishes by expressing the timber where that's possible, omitting the ceilings, cutting the numbers of trades on site, all coupled with a potential to be quicker in the on-site phase. And Paul is going to cover that a little bit later. So there is the possibility that the cost differential may well get closer in overall project terms than is shown here. Of course, if the programme is quicker, you also might find benefits in finance cost. Finally, I would add that factoring in the carbon tax will again close the gap between timber and the other solutions. So I hope that's been helpful. I'm going to hand over to Ollie now, who's going to elaborate on how to think about the building components and making them most cost efficient. Ollie.
Thanks, Steve, and a very good morning to everybody at home. We will now look more specifically at all the elements of the building that can be built from mass timber and some of our assumptions that the typical build cost ranges that Steve has just provided are based upon. We'll start with the roof slab. Structural roof slabs and terraces can be built from CLT. A waterproof membrane is applied in much the same way as would be with, say, a concrete structural roof slab. In our experience, we have not seen premiums from roofing subcontractors, nor problems getting warranties and guarantees for this trade. We'll now move on to acoustics. Now, there are various ways to deal with acoustics and different considerations. We'll start with impact noise. So this is noise transfer through the slab itself. Now, with this, there are potential cost uplifts compared to more traditional forms of frame. The first solution is to use screeds. The second, perhaps, is installing acoustic raised floors, which have acoustic pads under the pedestals, which is a premium on a more traditional raised floor that you might have in an office. Or you might utilise dense board with acoustic mineral wool. The second type of noise is noise bounce. Now, this will be the same as with concrete buildings, where solid surfaces are exposed internally. Naturally, noise will bounce. Therefore, consider cost for ceiling baffles and the like to dampen these noises in areas such as main receptions, on-floor net lettable space, or in meeting rooms. And third, flanking noise. So by this, I mean transfer of noise through partitions. This is dealt with in much the same way as with other frame types in the actual build-up of the non-load bearing partition itself. And again, just to highlight the importance of getting a competent acoustician as one of that team on board early to work through these things. Now we'll move to MEP, which is a very important one. Now, considering well-designed MEP layouts is a priority of mass timber buildings. Once the product has been manufactured and cut using precision CNC cutting machines in the factory, it will be expensive to make retrospective changes on site. If you're adopting a hybrid, so by this we mean a steel and CLT office, this is less of an issue if you're using castellated beams, providing far greater flexibility for service runs. However, glulam or LVL frames are less flexible for service runs as they cannot be castellated, and there's a limit to the amount and location of notching and creation of builders' work holes. The size and number of the notches in builders' work holes is limited as depending where they are and the number of them, as eventually this will undermine the beam strength, and your engineers will tell you about this. It's also worth considering the cost of cutting additional notches in builder's work hole in the manufacturing process before it leaves the factory for future flexibility in the future life of your building. Coordinating central corridor routes for MEP runs is advisable, and try to avoid beam interfaces wherever possible to reduce costs, as services, i.e. ducts, containment, etc., will need to go underneath the beams, far reducing head heights. Fixing to mass timber is easy. It's rather like massive patching, if you like. As with most offices, currently the trend is to have exposed services anyway. Therefore, the cost of galvanised containment will be no different. Coordinating frame design with a detailed MEP strategy is the key to cost efficiency, and you may want to spend a bit more time on this than you normally would. And perhaps it's just another very compelling reason for us all to adopt BIM. Next, the frame. By this I mean the columns and the beams. Now, utilising a standard steel frame for beams and columns with a CLT floor solution should be comparable to a typical steel frame element. CLT and glulam is typically made from spruce or pine. Other species are more expensive and there is less availability. The standard and most common strength of glulam is a GL24. Others are available, but higher strength classes can increase costs, and testing the market is advised. Our LVL, that our prices are based on, which is the acronym, as Steve said earlier, for the laminated veneer lumber, are based on the barbuka, which is a beech hardwood and is more expensive than softwood LVLs or glulams. LVL is manufactured in a different way to glulam, and you can see this process on the internet if you look it up. The Barbuka Beech Hardwood LVL is particularly favoured as an all-timber frame because of its significant strength. It's a GL70 over a standard spruce glulam, typically a GL24, meaning it can span far longer distances and the dimensions and profiles are reduced compared to the glulam. Glulam columns and beams have much larger profiles than steel equivalent, and depending on your method of measurement adopted, i.e. NRM or IPMS, can lead to a loss of net area when deducting columns or not from your NIA. The fact is that timber columns take up more floor space and timber beams reduce head heights. However, the timber columns do tend to get smaller the nearer the top of the building you get as loads reduce. So net area is improved on floor compared to lower down the building where the loads are greater. Floor slabs. CLT floor slabs are typically approximately 200mm thick, subject to grid layouts and spans. The basic rule of thumb is greater spans than 6 to 7 meters equals thicker CLT or introducing intermediary beams and thus higher costs. CLT slabs are typically 10 to 20% more expensive than an in situ equivalent, and visual grades fireproofing costs may need to be added depending on your design. In terms of the panel slab transport, the most efficient CLT panel sizes for transportation are 2.95 meters wide by 13 to 16 meters long, which is based on the dimensions of an articulated lorry. Bigger panels result in additional costs because loads need to be escorted, which is more expensive. But you want to use the panel as efficiently as possible because the more cuts, the more expensive it will get. Paul will tell us more a little bit later in terms of using panels most efficiently with piece count and logistics in mind. Cores. CLT cores generally are okay up to about 10 stories. Then the engineers will make you look at something different. Using CLT cores as the kit of parts speeds up construction. However, any higher and an RC core or another more expensive solution may be required. If a CLT core is pursued, ensure your approved inspector and relevant fire authority are brought on the journey as early as possible to avoid the expense of redesign if rejected later. Internal cores can be exposed, however the core will need to be fireproofed on the outside at 120 minutes to ensure fire compartmentation. Stairs. CLT stairs are readily available. Again, ensure the approved inspector and fire authority are happy with this and check on a project by project basis. The cost of CLT stairs is comparable to steel or precast stair equivalents. However, again for fire purposes, the latter can be more amenable to the building control officer and the fire brigade. Note the top surfaces of treads cannot be exposed as spruce and pine is not hard wearing like hardwoods, and therefore a covering wouldn't be required and require costing in the cost plan. The underside of stairs can be potentially exposed, again subject to sign off from the approved inspectors and consultants. And facades. The use of mass timber structure doesn't affect your choice of curtain walling within reason. However, heavier cladding systems such as a brick facade will increase loads on your structure and will therefore increase frame costs. So lighter weight curtain walling systems are more economical. We are seeing a trend at G&T towards adopting timber stick curtain walling facade systems, which are more expensive than their steel and aluminium counterparts. Notable examples where this is being adopted include Google Office and the Black and White building. These systems are more prevalent on the continent, and there are fewer subcontractors in the UK that have this experience at present. Matt, I think we were going to do a question at this point, weren't we? Is that right? Or?
Yeah. Well, we've got a number of live questions coming in, Ollie. Actually, so I'm going to choose one now. It's probably one for you and Steve, actually, from a cost perspective, because obviously it's got some implications. This question, but I've got an existing asset. Can I consider mass timber as an extension for it? So we picked that up as a cost question, I think, rather than an approvals type question. So, Steve, Ollie, do you want to just pick that one up before we go on?
Shall I go, Ollie? You want to chip it?
Yeah,
so,
yeah, definitely.
Yes is the answer. I think that's quite common. Certainly in an office, that's a solution that we would see. Clearly that bit around foundations and of course, if you're going on top of an existing building, being able to utilize existing foundations and having a light structure, I'm sure many of the engineers on the call would see that as a good solution. I do think, though, if it's residential or use that isn't an office building, you probably have to be far more considered and careful with that on the basis, of course, of concerns over dwellings and timber in the structure and cladding. But yes is the answer. Ollie, I don't know if you've got anything more to say.
I completely agree, Steve. I mean, what we're seeing, as you know, across the firm is a trend for clients to actually look at reuse of buildings. If you like, it's the win-win. If you have a concrete frame that's stood for 50 years and you don't have to send that to landfill, that's good from the carbon story. But then if you can extend up using a lightweight sustainable material like CLT, a glulam, an LVL, or a hybrid construction, then essentially it's the win-win in terms of sustainability. So we are seeing the trend to do that. There are some notable examples across the UK at the moment. The Republic building in Docklands, where they infill the actual an oversized atria using CLT and glulam, which meant they didn't need to do anything with the foundations. We're seeing a lot of popularity in OSD developments where there's little or nothing you can do to the foundations, and therefore using a sustainable lightweight material like CLT is advisable. And then there's the Cambridge Heath Road project out in Hackney for Ethical Property Partnership. Again, another good example of an existing building extended using mass timber. So absolutely, we might even see that surpass new build mass timber buildings in the future as we look to reuse our buildings rather than just send them all to landfill. Great,
thanks guys. We have got lots of questions coming in and actually lots of advice and opinion as well, which is great. So I'm going to try and summarise that at the end as much as we can. But let's move on, Ollie.
Okay, I'll just pick up now some of the other key cost challenges that you might want to consider when considering a mass timber building. So in terms of fire, there's a few different things to consider about. So first of all, some of our clients who still want to take the sustainable credentials are considering encapsulation. So by this, I mean actually using fireboard 60, 90 minutes to 120 minutes, depending on what your fire engineer advises, and therefore encapsulating this. And obviously this will have a cost to the actual fireboard itself. Then if you are looking to expose your CLT, you may well need a class 0 varnish, which is an application that may be required. The cost of this tends to be about 15 to 20 pounds a square metre on the exposed surface area. It's a different trade than the actual CLT or mass timber subcontractors. It's more of a painting trade. So it is worth factoring this in. And also, I just want to highlight the importance of benchmarking samples, etc., because different products perhaps will give a different finish to the CLT. So that's worth looking into. Then there's sprinklers and fire suppression systems. It's still advisable to factor in, even if your building is under 18 metres, as it tends to please the local fire authority and building control. And as we heard on the first session with the insurers, they also feel a lot happier about a building in use that's got sprinklers that's a timber building. I would also just throw in the mix here that it's worth considering mist systems, which are becoming more prevalent now, as they will cause less superficial damage should they go off. In terms of potential prelims uplifts, we've already covered project insurances, whether that sits in the development appraisal or whether that sits in the cost plan, and that's always worth checking with your cost consultants. There is a premium in insurance, and we've spoken about that and understand the reasons why. However, considering cost for 24-hour security or a RoboCam setup is worth doing, because that does alleviate pressures and makes the insurers happier. Allowances for mock-up samples and benchmarks, as I mentioned, timber is a natural material. As you might do with a marble or another natural material, it is worth checking who your supplier is, are you happy with the supply and what it's going to look like. And if you're applying varnishes or washes, it's worth checking what that will look like on a mock-up. So those kind of costs should go in as well. We talked about on the last session how water ingress is an issue. So there may be costs in the prelims for temporary protection to prevent water ingress, and the tendencies on removing water ingress, because we know that water will still get in one way or the other. That might be in the form of vacuuming and tendencies, etc. We've picked up foundations, Steve picked up earlier, and we just spoke about it then. Your timber buildings are significantly lighter, and therefore your foundation response should be cost less as a result. In terms of connections, check with your engineers and your architects whether they're specifying bespoke connections or proprietary connections. Proprietary connections are more off the shelf, they may have better testing data, and they should be more cost effective. Bespoke connections, which may be what you're after, will cost more money, and it's just worth checking what you're going for and what you're happy with. We've talked about the importance of grid layout and spans. As we said earlier, longer spans equal thicker beams or thicker CLT slabs, and therefore more expensive. And don't discount exploring hybrid opportunities as well. In terms of the material, approximately 50% of the cost of mass timber is in the raw material itself. So designing to use the material efficiently has a direct effect on costs. Less material equals reduced costs. So challenge if you are overspecifying thickness with the supply chain. In terms of species, we have already picked up that glulam and CLT prices are most commonly for spruce and pine, and it is just worth checking that. The reason is because they're fast growing and the most cost effective species for manufacture. Other species are available, larches, Douglas firs, etc., but they're more expensive and there's less availability. And we've touched on the barbuca as well. I will say, just on the chain of custody, that all European mass timber tends to be PEFC, which ensures sustainable and considerate forestry harvesting. Some clients have mandated FSC as part of their individual corporate commitments. However, FSC will cost more as it needs to be segregated from the other timber in the actual CLT factories, and that costs logistically a lot more money to the actual manufacturers. So question whether you need this chain of custody, as it will cost more, and PEFC is widely respected across Europe. I will say that the costs that we've given you are based on, in terms of glue types, are based on MUR or PUR glues, which are the most commonly used across Europe. Alternative glues can be more expensive. There are approximately 3 different visual grades, and some of the terminology tends to differ slightly from supplier to supplier. But essentially, the highest visual grade, which would be the top layer of the CLT, tends to cost about £20 a square metre more on the surface area. However, a lot of clients, when they actually look at the benchmark, are very happy with the industrial grade. So again, it's just highlighting the importance of benchmarks and testing. In terms of supply chain capacity, Binderholz, Stora Enso, KLH and Hashlacker have the largest capacity for CLT across Europe, and we will hear from them in January when they sit on the next panel. Manufacturing slots can become congested, particularly in summer periods, so plan ahead just in case and make sure you've made contact with them one way or the other. In terms of just another couple of few things before I finish, I would check on indirect savings that you might get depending on your chosen environmental assessment method, because you may find that using a sustainable material that has embodied carbon credentials might mean you don't need to spend money elsewhere in your environmental assessment method because you've got to credits easier. In terms of exchange rates, there's been a lot of flexibility. There's not been a lot of fluctuation in exchange rates since the big Brexit came out in 2016. However, mass timber costs have stayed pretty stable, but it is worth just keep checking in with the market. And in terms of Brexit, speak to your subcontractor and suppliers. They already have plans in place for this, and we'll hear from Andy Goodwin from BKS, who will pick this up in the next session. So we've covered a lot of stuff here. Please note that this is specific to offices, and residential costs and programme are different, and we'll intend to pick that up on another forum series. Importantly, none of these issues are insurmountable, and the team have been working up a risk register over our projects to ensure these and other issues are tackled head on for future projects. Matt, back to you, please.
Cheers, Ollie. Thanks very much. That's great. So let's carry on with our next slide. Great. So we're going to hand over now to Paul Robinson. Paul, do you want to take us through procurement and early subcontractor?
Yeah, thanks, Matt. Morning, all. As we've heard in the last forum from the main contractors, the earlier that we can get the mass timber contractor on board, it's going to streamline the whole system, efficient of design process. Everything will come together a lot easier. They will become a key member of the design team going forward, and it will help inform all the design consultants and help with actually defining the mass timber extent. It will also help define all the constraints that the timber structure has and highlighting any interrelationships between the different design disciplines. And these are all going to be considered early in the design process. Also, with the team including all the design disciplines, hopefully this will then make the build process more efficient and no major problems will be encountered further down the line. Of course, this will come with more costs. And Ollie, you did mention about the prelims, and I think this comes into that, doesn't it? So can you elaborate on the prelim costs a little bit on that, please?
Yeah, sure, absolutely. Thanks, we talked a little bit about prelim costs, but I think also it's worth bringing in the idea of, particularly on the larger hybrid or mass timber projects, of using a PCSA with the actual subcontractors, the mass timber subcontractors themselves. Whilst this is an upfront cost, we think it does give you a lot of benefits, particularly on the larger jobs, because you can bring the supply chain earlier and they can help you overcome a lot of the hurdles that we discussed earlier, and they can become part of the team before a main contractor is engaged. We know that a lot of our clients are listening now on the call, are doing this, and the feedback we've had is really good. The other thing I will say, just from a kind of a post-contract point of view, in terms of cash flow is you will spend faster on the frame. Manufacturer can average 24 weeks roughly, and as we picked up earlier, about 50 to 70% of the cost of mass timber is in the actual raw material itself. And therefore, the same way that you might look at doing a PCSA or bringing on facades and vertical transport packages earlier, it's certainly worth doing that as well with mass timber. So the client might want to consider considerations to advanced payment mechanisms, off-site material payments, or even a client direct order pool.
Thanks, mate. Okay, so then looking at the next section, the mass timber structure, we've decided that's what we're going to go with. The team are busy undertaking the design, and the mass timber contractor is now on board. This will all lead to further advantages. One of these will be the off-site testing, which can now take place early in the programme. It will de-risk both the design and the approvals process, and both site testing and mock-ups can be completed to allow any planning conditions to be discharged early in the process. And let's be truthful, when we look at jobs that we've done in the past, the structure and cladding performance mock-up and the visual mock-up end up being the same thing because we are compressing the programme all the time. Doing it this way means that we can get this team on board and we can actually do the correct sequence going forward.
Great, Paul. Can I just stop you there just for a second? I just want to,
yeah, sure.
Just want to get this question in before we leave the design and pre-construction side of the presentation. The questions come in. Can I decide? So this is probably one for you and I, Jess. Can I decide to swap to a timber solution at a latter stage of design of my project? Do you want to just answer that one? See if you.
Yeah. So as we kind of always say, anything is possible, but of course you lose some of the efficiencies and benefits of engaging early with timber contractors to inform your design process. You might also need to procure new design team members with the right level of expertise and competence in timber buildings, and also, as I mentioned, a peer review team to support that. You obviously miss the opportunity of having your earlier design freeze and the ability to engage with everyone from the beginning, but it certainly isn't impossible. I don't know, Matt, if you have anything else to add.
I think you're right. I've just written down some efficiency, grid size will be different or likely to be different. You've picked up on taking building control along the journey with you, and the earlier you do that, the better. You've picked up on peer review processes and indeed testing. If testing is required, you may have a slight delay in your program if you need to go back to test before you can proceed with design. So, yeah, I think it's about efficiency generally, but that's great. So, Paul, back to you. Sorry, you want to carry on?
Thanks, Matt. So now we look at the delivery strategy, how we're actually going to deliver this building. When we look at it, all factors of logistics have to be fed into this at this time. As with all projects, if it's not planned out correctly, then there could be some serious repercussions with the project build. The elements, we've got to consider all of them. So some of these include the component size. As we've heard from Ollie and from Jess, that the mass timber sizes tend to be bigger than others, the steel reinforcement, things like that. So early, we can establish this size and we can understand the routes and the sizes of vehicles that are going to come to site. And at this point, we can talk to the local authority, come up with the best locations, the best routes through London, through other areas of the country. Then this will lead on to the actual on-site works. So then we've got the pit lanes. We can understand early what size of these pit lanes need to be to accommodate the vehicles that we're using. And these can be put in the correct location to allow easy offloading and onto the site for erection. We'll need to look at finalising the laydown areas. So as we've previously mentioned, the timber tends to be bigger. And if we can't fit it on a really large wagon, they need to come in component size. So therefore, we may need a laydown area so we can actually form these on the ground. Large components unfortunately won't fit on these wagons. So we will need that laydown area. It needs to be somewhere local to the site. It needs to be somewhere easily for the work face so we can lift it straight on once it's been formed. And then you've got the crane strategy. With all large structures, the lifting strategy is key to the frame. The piece count and the program for the structure needs to be understood as early as possible. Whether the project requires 1 or 2 hooks to hit the target program. The location of the cranes, we need to keep them outside the building footprint to ensure water tightness at the best of our ability during construction. All these need to be considered. Options for on-floor cranes to install the CLT floor panels and on-floor manipulators to install the cladding to release the main hook for the structure. All of this needs to be considered early in the project. So then we look at once we've got the main logistics sorted, we then need to understand when and how the building is going to be erected. So is there a requirement of temporary works to allow the structure to be erected? Any temporary propping that's needed to ensure the integrity of the new structure during erection? This can all be finalised really early in the process with everybody on board. And then you look at the programme of when it's actually been erected, and we need to take cognizance of all the factors that could affect the erection. For example, the time of year we're undertaking it. Is there a chance of winding off? needs to be kept to a minimum to not impact the process? How is the timber to be stored both during erection, on site and off site? We need to protect the timber from water ingress and fire. How will the CLT floor panels be installed? Again, this needs to be away from the hook if possible to make sure the structure is the key. Temporary fixings for handrails. These need to be installed within the structure as it proceeds to ensure safety on site. Cladding fixings. Again, as we previously mentioned, these may need to be on board early so we can get the fixings into the structure early and it comes to site already fitted. Any fixings that need to be done afterwards may compromise the structure and will add time to the programme. Fixing of services, as Ollie mentioned, these need to be developed into design early to allow the correct apertures to be incorporated. This will, of course, limit changes later down the line, providing less flexibility, but does need to be incorporated. There will be a requirement to do off-site testing, off-site inspections to ensure the fabrication is completed as per the requirements of the programme. And it may also be worth finding a consolidation area within the UK to ensure that deliveries are not compromised, since most of the components will come from Europe. And then I think, Matt, I think at this point, we're on to the construction. So I think we've got a poll question now.
Yeah, I want to do the last poll question now, Paul. So thank you for that. So let's get that up on the screen if we can. Okay, so off-site testing can be expensive. Would you consider collaborating with other developers on bespoke testing, on a bespoke testing program for these materials? Again, a simple yes or no. Shouldn't take long to answer, but obviously this is aimed more towards our client base and our developer team. But if you'd like to answer that, that'd be helpful. I'm going to do a drum roll, but drum rolls now playing. And the answers have come in, and we have. Yeah, definite yes, fantastic. So yes at 95% and no at 5%, and that relates back to some of our previous panels actually, whereby there's a big need for collaboration. That's great, thank you for that. Right, so moving on. So during construction, we've got a piece now on construction, and back over to Paul to take us through these pieces. Thank you.
Thanks, Matt. So now we've looked at the pre-construction elements. Hopefully this programme is starting to fit all together seamlessly. However, there are considerations we need to do for putting the construction programme together and understand really if mass timber is still the correct solution. So there'll need some parameters for this programme. However, to do this, we need to have a few considerations. So what will the critical path be? When looking at the various buildings, they will need to understand where this critical path will run through the construction sequence. For a low-level building, this path may be running through the first 6 floors of superstructure, allowing the cladding to commence, then into fit-out and commissioning and testing. For a high-rise, this critical path alters and goes through the installation of the roof plant, and therefore the structure becomes the key activity, meaning the quicker the structure can be erected, then the shorter the programme. That leads then into the foundations that we're going to use. So as with all buildings, we start at the bottom with the use of the mass timber. As Steve always suggested, there's no doubt that the loads being transferred down onto the foundations will be a lot less than with steelwork and concrete. Due to this, there may be a reduction of the number of piles that are required, maybe less sizes as well. This will shorten the on-site piling activities, which will be a positive on the programme. Then within tight areas, you also find at the moment we're building more and more basements. So with a 3 or more basement being installed on a structural frame of steelwork and metal deck, there is to try and get with the structure being the key to getting the job finished, and with the critical path running through the roof plant, people tend to try and look at an on-site idea of using a top-down solution. So on a 3-story using a top-down solution and the introduction of plunge columns, this will, sorry, I'm having a bad day, so my apologies for this. So, yeah. So when you're looking at a top-down solution and the need for the plunge columns to be installed, the sizes of these will vary depending on the loads being supported. For a steelwork solution, these tend to be on a 3-story basement cost neutral, with the plunge columns being negated by the savings on the prelims. When you look at a 2-story scheme, though, that tends to change and the cost exceeds the program benefit. However, if you then start to introduce mass timber that has a lighter structure, it might mean that the cost and the sizes of the plunge columns and the numbers of plunge columns will actually reduce. And therefore, it might start to prove cost neutral to do a 2-story basement on a top down with a mass timber structure. Again, improving the program. Then we look at the speed erection of the actual frame. Generally, there will be no difference, sorry, between a steelwork structure and a timber structure. The key is the piece count and the number of pieces that can be erected in one day. This can vary depending on the location of the site, but overall there won't be a significant difference between steelwork or mass timber. Further to this, program may dictate how many hooks that are needed for the frame to achieve the output rates required. We need to look at this early as we can. Then you look at the type of floor panels that are being used. It's always better to try and keep the tower crane, especially on a high rise, away from doing floors and just concentrating solely on the erection of the frame. For this, then you need to size the floor panels to the correct size to allow the distribution and installation on floor. Design needs to take the minimum number of lifts of the floor panels to the floor level, and then hopefully utilize an on-floor crane to distribute and install at floor level. This needs to be careful consideration early in the program. Then you go on to the cladding installation. At the moment, the quickest cladding we see on sites is a unitized system and installing that from the slab. To undertake this on a floor, the floor would need to be free of all propping and available for the cladding contractor for its exclusive use. For a concrete frame, this point would be around level 9. For steel, metal deck and concrete slab, this would probably be around level 6. For a mass timber, this may well be earlier and could be brought on a lot earlier, but however, we need to take cognizance of the floor-to-floor cycle of the structure. The cladding cannot be allowed to catch the structure.
Well, just there, I've just had a live question in, which I think is quite appropriate at this point to ask you, actually. The question, can I really take the full potential program benefit of using timber if I can't get my cladding and lifts, for example, any earlier?
I think it all depends on the size of the building. That if you've got a smaller building, not high rise, where the critical path is running through the cladding, then correct, it's going to be very difficult to get that potential benefit. But however, we have already spoke about the cladding contractor will be on board as early as we can. 9 times out of 10 as well, we get the lift contractor on board as well. So hopefully, if you've got the whole team together, that will give you that program benefit. So I think you can take it, but you just got to watch it. On a high rise, the cladding guy, you need to watch when he comes on to make sure he's there in time to put the fixings in, but it tends to run through the roof plant. So it's not quite as difficult to get that benefit on a high rise.
Okay, thanks, Paul. Carry on, mate.
Okay. And then there's just 2 more things that I'd like to mention that are not directly program related in respect to the output, but they do need consideration. So the first one is resources. It's always a factor on constructing a building, the size of the welfare, access routes, and at the moment, as we all know, even more so with the current restrictions that we have. So the resources required for a main structure will be relatively the same for both steelwork and timber. It's when you look at the construction type of the slabs that are being used that it will change. For concrete slab, there is a massive uplift of resource required to install them compared to what there would be for a CLT. This will, of course, if we can reduce the resources, we get less welfare space needed, thus less prelims. And then finally, the time of year. As Ollie's already mentioned about water ingress, as we've previously noted, there is a need to look at when we're actually erecting this structure. Higher winds, as well as wet and cold weather, will impact the certainty of the timber frame erection. Further future defects issues may also be prevalent if we install in the winter months. The contractor may need to provide more protective measures during the bad months to ensure the quality of the product. And that really sums up where we are on construction, Matt. I'll hand back to you just to finalise.
Thank you, mate. That's really good. Thank you. So we've got about 5 minutes left, and I wanted to have a chance just to have. We've had loads of questions coming, so thank you all for that. So probably I'll start with this one. So probably to Steve and Ollie, more of a QSC type question. Early in a project, it seems to be much easier to get a firm handle of cost for a traditional build. Is there an effective way to firm up the cost of the timber components early in the program? I also have more fluctuation in the price of timber. Is there any commercially viable way to hedge the cost of timber elements once you have a sense of the volume you are purchasing? guys, that's a good question.
I'll kick off with that. I saw that coming. I think that it comes down to that point that both Ollie and Paul made about early advice on the timber, getting your team selected, and potentially getting fairly early into a PCSA with the timber contractor. Clearly, there is cost data that we have of other timber buildings, and we can bring that to bear. But as we've said there's can be quite a variance in the solutions, the timber solutions. So it's not always that reliable. So I can understand how you might be struggling there. But our recommendation is certainly to get some good early cost advice from the specialist trades, and that's certainly something that we do pretty regularly. I'll just cover off the other point too, if I can, and Ollie may or may not have something to comment, which was the bit about trying to get certainty around the cost. That maybe that's around exchange rate. From that point of view, we don't particularly see it too much different than we might see the lifts package, VT package, or cladding, which so regularly comes from Europe. Main contractors and trade contractors are often prepared to fix the exchange rate. Yes, it will come at a cost, but they might be more able to do it than you can if it's a smaller build. So that's probably the way that we'd look at that. Don't know if you've got anything else out there, Ollie.
Yeah, I agree, and I think we'll hear from the subcontractors and suppliers in the next session, but they themselves obviously hedge their bets way in advance as well to try and handle that risk. And I think it is about talking to the supply chain and negotiating, and PCSAs are definitely a good vehicle for doing that.
In fact, look, we've had a few questions about Brexit and COVID and disruption of supply of materials and the like. And I guess, Steve, that a lot of those will relate to timber being like any other product coming from abroad or coming from Europe in that sense. But yeah, I think that's
right. I think it'd be nice to be able to give everybody a clear answer. I think the most of the UK is looking for that clear answer on Brexit at the minute, but in fact, it's something I looked at more widely recently for some clients, and part of the question that I've seen come in was about levies, and do we know what that is around timber? I think for most building products, we do already know what the levies will be. They are, in relative terms to a construction cost, quite low. The issues that will exist over time with Brexit are going to be about specification and a divergence potentially between Europe and the UK in how specifications are written. So not being able to get a particular kite mark or a particular stamp on the product might cause some delays. I don't think that will happen immediately. And the other one, of course, as I think many people know, is going to be this issue of ports and getting materials through it. That said, with timber, you know pretty early on what you're doing. It can be manufactured early. And to Paul's point, if you're going to need a laydown area anyway, then you have the ability to get the materials across early. Will affect your cash flow, but it's probably the safe thing to do.
We've just about run out of time for any more questions, but we've had lots of opinion as well as questions. So we'll weave those into our report, everybody. Things like, one supplier for LVL, it's expensive, it's not great during inclement weather. That's come from Matt Linegar. Mark Punsat's got some views in relation to building control. All great stuff. There's one here as well about the mix of timber, spruce GL24 and beech GL70, giving you larger spans and transfers. That sort of stuff we might link into one of our engineering sessions later on. So all great questions. We'll pick them all up. But what's up next? Let's have the slide up next. So next up is capacity, supply chain and procurement. So we've got a great panel there. For those that are in this world, you will recognise all of those organisations, and you probably recognise the people as well. So we're looking forward to that. That's going to be on Tuesday, the 12th of January. So it will be the second Tuesday of the month rather than the first, which is our normal. We thought we'd give you all a bit of an extended Christmas break. So that's that. And then really, lastly for me, thank you all so much for joining us today. Any questions for that next session, or indeed this one you want us to follow up on, please don't hesitate to email masstimber@gardner.com. And that just leaves me to wish you all a very Merry Christmas and look forward to seeing you in the new year. Take care, everyone. Thank you. Bye.